First of all, just let me introduce myself. My name's Barry Pollard. I'm a software developer based here in Cork in Ireland. I currently work at an Irish healthcare company, managing a team both front end and back end developers. Outside of my day job, I'm heavily involved in the web performance community. I blog at tunetheweb.com, and there I post blog posts on how people can improve their website, a lot on performance, but also other aspects of it. I'm pretty active on Twitter, where you can get me at tunetheweb. I also contribute to open source projects when I have time. I spent a good bit of the last year working on the Web Almanac, an annual State of the Web report that was launched at the Chrome Dev Summit last summer. It's a great resource. I encourage you to check it out. I wrote the HTTP2 chapter on that. And I'm also the author of HTTP2 in Action, which Manage published just over a year ago in March last year. And that's why we're here today. Today we're going to look at some of the websites, see how they could benefit from HTTP2 by doing some live analysis. I encourage you to put some websites for me to analyze into the chat. I'll be keeping an eye on that. So live analysis, multitasking, and this is my first time on Twitch, so what could possibly go wrong? But we'll see what we can do with that. I have a few sites I've picked out that we'll get started with, and they give a good introduction to what we're going to see. And we'll work through those. But I'm more than happy to actually look at some of the sites that you suggest, either sites that you work on or sites that you visit that you're interested on, and we can have a look at those too. So please, as I say, drop some suggestions in there, and we'll try and do that. As I said, this is the first time I've ever live streamed, so wish me luck. And we're all aware that the internet is under enormous strain these days. We're all working in a different world. So please do bear with me if I or the technology doesn't perform as well as it should do. We'll try and work through any teething issues and try and get there. For those of you that own the book, I'm going to be working similar to some of the analysis I did in Chapter 2. So this is the ebook there. In Chapter 2, I worked through some real live examples there. I looked at Amazon.com and also Imager and worked through some waterfalls there, showing where potentially they could gain by moving to HTTP2 and some of the pitfalls to look out for. Since I wrote this chapter, both those sites moved to HTTP2, but I kept them in the book because I thought they were good examples. I think we'll pick a couple of different examples this time. We'll try and work through them, and then we'll see. On that point, I would say it's getting increasingly difficult to find websites that aren't on HTTP2 yet. I think it was first introduced in about 2015, but a lot of the major mainstream websites have moved to that. I think some of the smaller websites that perhaps you work on are still taking some time to come from, depending exactly how you host it. If you're going through a CDN, you may have got it for free already. You may not even be aware you've got it. But a lot of the major sites that are good for demos like this, because you'll have used and you'll be aware of them, have already moved. So they make for less interesting demos. But we'll also look at a couple of examples there that have moved and see the improvements that they got with that. So let's get dived in. We're going to 2 seconds. So we're going to use a tool that some of you may be familiar with called Webpagetest. This allows you to just plug in a website. It's a free tool that's available online at webpagetest.org. Allows you to plug in a URL. It will do some analysis on the website, and then it will show a breakdown of those things. There's a lot to this tool. It seems fairly simple whenever you first go in there, but there's an awful lot of detail in here. So we're only going to scratch the surface of what we can do there. I see someone's recommended the NHS, which was one of the first sites that I was going to actually analyze. So that's good timing. So we go in here, we just type in the website that you want to look at, which is the first one I was going to pick is the NHS. That's the National Health Service in the UK. We're going to look at it from London because it's a UK-based site. So there's a number of sites that you can pick here. Also, I'm hoping at this time of night, London's going to be fairly quiet, so there won't be a queue. Well, there's a couple of advanced settings you can pick here. We're going to run it as 3G fast. Normally, I would advise you to run the 3 tests. That way, one test slightly stumbles or trips or gets stuck. You can pick one of the other 2, and it will take an average of the 3 sites. Just for speed reasons here, to make them reasonably quick to run, so we're not hanging around waiting it, I'm going to knock that down. I'm only going to run the first few. Sorry, I'm only going to run 1 test site on that, so hopefully it won't stumble and we won't have to rerun it, but that'll just make it slightly quicker. So there's a lot of other settings here, and we'll go into some of them later, but that's the basics. Is you type in the URL, type in the speed that you want, the location you want to do it, which browser you want to test for. Chrome has an awful lot of options. It exposes a lot of data that Webpagetest can pick up on. Firefox has got a lot of data. Safari, less so. So you're better picking Chrome if you want the full gamut of details here. But of course, that obviously depends on who visits your site and what browsers they use. And if you look at Google Analytics, you can see you get a lot of Safari visitors because you've got a lot of mobile traffic and it's very popular in iOS. You may want to test there, but we'll stick with Chrome for the moment. So say you plug it in, you hit start test. That will then fire it off to a server where I'll be waiting at a queue. We're in luck, we're at the front of the queue. So that'll just take a couple of minutes to run there. And basically what it does is it fires up Chrome in the background, it loads the website, then loads all the things that it needs, the web page itself, all the CSS it needs, all the JavaScript it needs. It's running the full Chrome, so it's executing any JavaScript. It's loading any images it needs there. It's basically the full experience there. And then Webpagetest will be taking various details, various logs of what's running when, and it will display it in a nice method for us to analyze and look through it there. While we're just waiting on that, we can go through some of the other settings that you can also pick. I'll just do this just while I'm waiting on that, and I'll flick back and forth just to check there. So as I say, you've got the test location there. Most of them run the normal desktop browsers, Chrome and Firefox. If you do want to check on an actual device, these are devices, they're real devices plugged into the system there, but there's normally quite a big queue with those because there's limited numbers of those. I think they run under Patrick Mean's desk that runs this site, so it can take a little bit longer there, but they can be useful there if you want to look at specific things on mobile device, because you can get an awful lot of data there that you might not get just from browsing it yourself. And we'll have a look. Yeah, that's not gotten stuck there. That could just take a couple of minutes. I've got a couple of backups if we get completely stuck, but I'm hoping that will actually take a little bit of time there. I've talked about these 2 options. There's also this first and repeat view. So typically whenever you go to a website, it will cache a lot of data, and then the next time you go to the website, if it's shortly afterwards, it will be in the cache. It will load up very quickly, and again that can be quite a performance enhancement there. So this will run it in both view. This first view will run it a little bit quicker because it will only run the first view. And then you're getting a clean cache, you're getting what a typical visitor would look like the first time they come to your website. But if you have a lot of repeat visitors, then you might be more interested in the repeat view. Capture video will capture little screenshots all the way through as it's downloading and creating the website, which can be very useful to compare and contrast, or to actually see as the website is being built. And you can give it a label, but you can also give it a label later that we'll have a look through there. What's going on here? Tell you what, we will, just in case, we will kick it off on another location. Let's pick the default, and we'll just race them and see who goes first. While we're waiting there, because that one seems to have got a little bit stuck. I'm not sure exactly what's going on. Whereas this one test has started there. So I'm not sure if there's a problem with the London instance of Webpagetest, or if it's just waiting on someone else in front of me. It does say I'm at the front of the queue, but doesn't. Maybe there's only one person ahead of me that's holding the thing. So yeah, we'll just give that a couple of seconds to run through. And test complete. So as you can see, it's very quick to actually run, depending on your site and depending what settings you choose. If you choose a slower setting, obviously it can take a little bit longer to run. So you get a wealth of data here, and let's say we're not going to go through all this. There's various RAG status up here where it tells you certain things are red, amber, or green, and you can click on those for more details. There's a number of details here and breakdown of what makes the site. There's some stats up at the top here that say, look, as I mentioned earlier, the first view and repeat view. So in the first view, the first byte, before you even got anything, it took a whole second to actually get the first bits of the page back, and we'll look into why that is in a minute. After about 2.5 seconds, it started rendering or drawing the page. And slightly before that, which is actually impossible, but then these timings are not 100% accurate, so pretty close, but about 2.5 seconds, it started drawing something that was meaningful. So the first render might be it's just putting a blue background on there. That's not that meaningful, or a white background, whereas the first contentful paint is when it's actually putting something text there, or an image, or something a bit more meaningful than that. Speed index is a measure of how the page is progressing. So you could have a page that does absolutely nothing for 5 seconds and then suddenly shows the full page in all its glory, or you could have a page that shows a little bit of the menu, a little bit of text, and then a little bit later it shows an image, and so on. The first one there would have a low speed index because it's waiting till right at the end, and then you get the full glory, whereas the second one there might have a higher speed index because what it does is it measures and sees, okay, well, you're giving something back to the user there, and that's normally better. Last painted hero is when's the last major bit of the website, be that the H1 tag or a hero image or something there, something important, so rather than just the body text. These two items are fairly new. They were only added in the last week or two. The largest contentful paint sounds very similar to the first contentful paint. This is just the first bit of drawing, whereas the largest content paint is the largest important bit of the image. That could be the biggest banner that's showing on the page. It could be the main text that's showing on the page. And again, we'll talk about that later there whenever we go through some of these examples. Cumulative layout shift is, again, it's a fairly new one. What it does is it measures the pages moving around. So typically a website will load first, you've got text there, you're starting reading it, and then suddenly a banner pops up. I live and work in Europe, and we have got the bane of our lives is all these cookie banners. So they would typically come in and shift everything down, and it's quite irritating because you lose your place in your text, and you're like, oh, where was I? And you have to scroll up and down and find where you were to continue reading your text there. So this measures how much of that's moving around. Typically, you want less than 0.3. Less than 0.1 is very good, and it's hardly shifting at all. 0.1 to 0.3 means it's shifting a little bit. This here shows a good shift, and again, we'll show why. I suspect it's a cookie banner. The total time that it's taken to give the document complete. Now, we're way past the stage where you download a website and just read it. Most websites are sitting there and they're talking in the background, whether it's sending analytics, whether it's getting additional contact, whether it's those infinite scroll ones that are getting more data as you scroll down, whether it's Twitter or Facebook that are getting new feeds coming in and pages updating. But this is typically when the first document is complete as it is, and it says, right, okay, now I'm ready here to present it. You can start interacting with this page. This shows the number of requests, and that's going to be very important for what we're talking about later on with HTTP1 and HTTP2. The number of bytes in, so that's how big your page is. That's quite small. I mean, the median web page now, I think we're up to about 2 megabytes there, so this is about half a megabyte. The joy of working with some of these government websites like the NHS is they don't pile on loads of trackers and ads and other things there, so they're usually quite light. And then this is the fully loaded, so this document complete is when the page is kind of there, but as I say, there's usually stuff going on in the background there. This is the bit that I really want to get into. This is the waterfall, and we'll go into that in more detail, and we'll also go into the film strip, so I'm going to get that going in the background. So here is our waterfall. When we click on that, there's more detail here. So typically whenever a website is drawn, we fetch the index.html. Then we see it needs some CSS, some images, some JavaScript, some more images, a bit of fonts, and all this. So what this view shows you is all that, what it takes to build this website. So first of all, we're starting on, I typed in www.nhs.uk. I didn't clarify it with HTTPS. So the NHS is actually on HTTPS. So the first thing it did is it had to find out to do a DNS lookup. So these are all color coded, and there's a handy key at the top here. So I had to do a DNS lookup, and we as humans deal with domain names like www.nhs.uk. Computers deal with IP addresses. So first thing it has to do is convert that domain name into an IP address. Then it has to connect with that. So this orange connection is typically a TCP connection. So it's opening here to port 80 from your computer. There's a bit of a three-way handshake to go on there saying, okay, I'm going to start connecting. I'm going to send packets beginning with this, and you're going to respond with that. And okay, are we happy? Yep, we're ready for sending that first request. And off we do that. I enjoyed the web page test queuing as analyst to the NHS waiting times. Thanks, Emma, there. That's maybe a little harsh with what the NHS is going through this time. Let's keep up the chat going. So yeah, as I say, at this point we've made the connection. We're saying, okay, give me the web page. And the first thing it does is it returns a 301 and says, I'm actually prefer you to go to, well, actually I'm instructing you to go and load this over HTTPS. So please go ahead and start that all over again. Webpagetest colors these in yellow to say this is a redirect. You didn't actually get any real data here, and start over again. So here we see there's a nice little padlock, and we start the whole song and dance again over HTTPS www.nhs.uk. So that's the first thing there, is we've wasted a whole half a second there just waiting to connect that. Now on the UK one, that might be slightly less. I don't know if NHS is behind a load balancer there. I suspect it is. I don't know if it's a global load balancer. So it's probably not too different. That still seems fairly fast there. But we've wasted half a second there before we've even got to the real request here. So the first thing that you want to do is whenever you're putting links there, make sure you put the fully qualified HTTPS link in there, and not just a www where the browser will default to HTTP, and certainly not if you're going to the hassle of including the protocol, then include HTTPS and not HTTP2. You can also use a setting called strict transport security, which is HSTS, which will tell your browser, hey, I'm always going to be in HTTPS. Next time, just skip this whole song and dance and go straight to HTTPS. I don't care what the user typed into the browser, go straight to HTTPS. I'm telling you now, that's all I'm going to use. So that can be a handy thing there. We're getting slightly off the track here of HTTP2, but I think a lot of this is important information that will serve us in good stead later. So here you can see we make the same connection. We don't need to do the DNS lookup because we know what www.nhs.uk is, and the redirect has just redirected the protocol. It hasn't redirected to a completely different domain. So we're staying in the same domain. We know what the IP address is, so we save a little bit of time there. But we are making a new connection. So HTTPS is on port 443. So we have to make a brand new connection there. We have to do that whole TCP handshake and song and dance again. Then we've got this purple line that wasn't there before. So that is the SSL connection. So that's the HTTPS, the secure part there. Often called TLS now, which is more strictly accurate because SSL is an older version that's not secure, but in a lot of documentation people call it SSL just for habit, or SSL/TLS, which is a bit of a mouthful. Regardless, they're kind of synonymous, so don't get yourself too worried about that. So it's got to set up there and say, okay, what ciphers do you support? What one are we going to use for this? Okay, let's encrypt the key. Fine, this is how we're going to do the encryption. So there's a bit of back and forth there while it does that and connects up. And then we ask for the website. So we're saying we want nhs.uk, which is typically index.html or by default. The browser then, so we make that request, and then the server, sends back the web page to the browser. The browser then reads it and goes, okay, I can see I need some CSS, I need some fonts here, a couple of WIF2 fonts, I need some JavaScript, and so on and so forth. So as it's getting the page back, it's reading that HTML. It doesn't necessarily wait for the full page to come back. Browsers are quite smart and quite clever, and they'll just start streaming the HTML as it comes in and reading it and browsing through it and seeing what resources it needs. So let's in another tab, let's actually NHS, load up the NHS website. So there we go. And there, boom, there you see that big cookies thing that I was talking about. So if we look at the page source of this, you can see here, there's a big white gap for unknown reasons, but we'll not worry about that too much. So there's some metadata that doesn't really affect us here. That's more to give some information to the browsers or search engines or anything like that. Here you can see a pre-connect there. We'll talk a little bit about that in a minute. We're also preloading a couple of fonts. Again, I'm going to skip that for now and come back to it. And here's our first real bit of content that we want. So we're wanting this style sheet. And you can see back to, I'm getting a bit confused here with so many tabs. There's our first style sheet. So we're saying we're going to need this style sheet. Can we please download it? So then that goes off to the server gets the style sheet, and it comes back. Typically, once you see the style sheet, you'll see you need other assets there. So, we also need some fonts. And the fonts are often late loaded because they need to wait for the style sheet, the CSS, to actually see that the font's needed. Typically, that won't start until after this. The NHS has been a little bit clever, and it's put these preload hints in there where it sit there and said, you're going to need these fonts. I know 100% you're going to need these fonts. So why don't you go ahead and get started, and don't wait for the CSS to tell you need them. I'm telling you right now, you're definitely going to need them. So it allows the browser to make a bit of a head start there and start downloading those fonts rather than starting that later. What you will notice is that the fonts are served on a different domain, so that's assets.nhs.uk. And this was a fairly common pattern, still is, but definitely in the past. This was a way of offloading from your main domain some of the things and saying, okay, I'm going to put all my images, my JavaScript, my CSS, I'm going to put them all on this separate domain. And yeah, that frees up the main domain. It also allows the browser to make some extra connections. So a browser will typically limit the number of connections to a domain to about 6. So whenever you want to download at the beginning, you want 2 font files, 4 CSS files, 10 JavaScript files, and 100 images. If you're limited to those 6 domains, 6 connections to those domains, then only 6 of them can be in flight at once. By opening up a separate called sharded domain, you've got another 6 there, so you can download 12 connections at once. Not strictly true, and we'll show some examples where that isn't the case, but roughly that. The reality, though, is that that's quite costly. So if we look at this font, we have spent, let's work it out there, about 0.8 of a second making the connection, and then a third of that just downloading the font. So 3/4 of this time of this asset is just spent making the connection. Now, granted, you can use it again later, and we'll see down below how much that is used, but there is quite a cost to that. Whereas if we hadn't done that, this would have started downloading the fonts here whenever the connection freed up from the CSS. So it's actually, it looks like an optimization here, but you're actually costing the fact that it's on the separate domain. Yeah, you started it a little bit earlier, and that's good and all, but you've still got a cost and a delay to that. And that's another thing that we're going to see that HTTP2 can help with and see. Then we scroll down, we see we need a cookie bit of JavaScript, so we're getting that. After that, some further bits down, we see some more JavaScript, then we get some of the images, so these JPEGs. And you see they're nicely color-coded here so you can actually see what the images are. We also need another, what's this one? Another asset. So we have 2 connections to assets.nhs, 3 connections because the JavaScript's on there. They're downloading, and then whenever these 2 items are needed, that can reuse one of the connections earlier. Oh yeah, we'll come into it. Fonts are basically kind of special. They are basically downloaded over an anonymous connection, particularly whenever it's cross-domain like this is. So whenever you're not downloading the main across the main domain, it will open a separate connection for certain requests using a horrible acronym called CORS that is very difficult to understand. I'm not even going to attempt to explain during this time. But basically, fonts are kind of special. They use their own connection. Just take it for that. Which basically means this third connection, this assets.nhs here, where we're downloading JavaScript, once that was finished and we had this other request here, it could use this. However, whenever we had this request, it couldn't use that. Look at this big long one here, it's sitting there waiting. So it had to open another connection to assets.nhs. It had to do another TCP handshake, had to do another SSL handshake, and yeah, it kind of set that up in advance just in case it was needed. But then it could use this to download that thing. Then we're back to an SVG, which for some reason is hosted on the main domain, so that's free because it hasn't been used until this, since this CSS. Oh no, yeah, there's a couple of JavaScripts here, but that domain was free. So you can see this little line here is where it's waiting and saying, I'm not going to bother opening another connection because this one's nearly done. Downloads that, another bit of the assets, then a bit of the banner feed. Then it's got a whole load of assets, a whole load of images to download here. And at that point, it says, okay, I'm going to need some even more domains here. So make some more connections and so on. There's a very handy connection view here further down. So this shows the exact same thing as this, but it's grouping up all the different assets into each of the domains. So you can see we ended up making 3 connections to nhs.uk. We ended up making 1, 2, 3, 4, 5, 6, 7, 8 connections to the assets.nhs.uk. I say that's because 2 of them were on fonts, so they're the special ones. That's these red lines here, and then we get maximum of 6 connections for all the other assets, so the JavaScript, the images, the CSS, and so on. Other things you see here is the CPU utilization. This is a very simple site and basically just downloads and displays the images. JavaScript heavy sites you can max out in CPU here, so that's a thing to keep an eye on. But what we're primarily more interested in is the bandwidth here. Now, this is a fast 3G connection, simulated connection. If you remember, we picked that at the beginning. So there's not a huge amount of bandwidth here. And it's basically maxing out from about the 1.5 seconds in until it gets to about 3.4 seconds. So that has 2 consequences here. One, because we've the 6 connection limit, it means that some of those images are holding that connection for a good bit longer, whereas you may have a queue of assets to get. The browser can't actually send those yet because it has to sit there and wait for one of those connections to be free. And that's one of the big things HTTP2 helps with. So HTTP1, and we'll not go too much into the protocol here, but basically HTTP1 is a text-based protocol. You sit there and say a number of text-based commands where you've got a method like get. So get /index.html. And then you hit return, it goes across to the server, it gets it, it comes back as a stream of text bytes in effect. If it's anything other than text, like it's an image, there'll be some headers to come back and say, hey, I'm going to send you some real bytes, for want of a better word here. But primarily it's lots of text messages back and forth going through there. HTTP2 works slightly differently in that it wraps everything up into a frame, which kind of like, think of it as like a TCP packet. So it sits there and says this packet belongs to this stream, and you can have multiple requests running at the same time. So that means you don't need to open all these 6 connections for each domain. You can just have one connection, and you can have lots of little envelopes passing back and forth between your browser and the server. So that means that we can really use that one connection to its most efficient capacity, rather than having to open up multiple connections like you can see we're having to do here. Now, you may think to yourself, well, surely 6 connections is better than 1 connection because you've got as much, you've got 6 times the capacity. That's really not true. You've got to remember these are virtual connections. So you probably just have one Ethernet lead into your computer or one Wi-Fi connection to your router. You don't have 6 connections. So these are all fake and little virtual connections that are set up between your computer and the server. There's still probably only one pipe unless you've got multiple network cards and things like that. So everything's coming down that one pipe anyway. But what is different is at a protocol level, we have to do these very expensive connections, these TCP handshakes, these SSL handshakes, because they don't know they're using the same connection. They're just sitting there going, okay, as far as I'm concerned, this is a completely independent connection from the previous one. So let's start again from scratch and let's do that. And as I say, you can really see here in this graph that they can be quite expensive. So if we were using HTTP2 on this site, basically this whole chart would shift left a little bit because everything could happen just that little bit earlier, which basically means that all the downloads can happen earlier and all the subsequent quests can happen later. And then the other point to note is that TCP is quite a conservative protocol. It starts quite slow, feeling its way. It's not sure at the beginning whenever it connects up, am I on a 3G slow connection or I'm on a super fast office internet connection. So it starts quite modest and says, okay, I'm going to use this speed and then I'm going to try and increase it a little bit. No, that seemed to work. I didn't get any complaints. I'm going to try and increase it a little bit more. And that's a process known as TCP Slow-Start. And it takes a while to feel up until it gets to the full capacity of the network connection. At that point, it sits there and goes, great, I've got the full connection. I can sit there and use that to its full capacity. But whenever you're opening new connections, each of these new connections has to go through that same build-up and go through that same initial slow method and get up there. And if we look again down at our connection view, like these last few ones, they were used to download one asset, basically. Here we can see we're requesting this and then we get the result back here. We're requesting this and we get the result back here. So it's almost a waste to kind of open up a full connection, go through that whole connection rigmarole, go through that SSL rigmarole, go through that TCP Slow-Start song and dance just to download one and say, actually, by the time we've gone through this, the rest of the website's already loaded. Let's just shut down this connection and start on there. Again, that's something that really HTTP will utilize the one connection that will get up to full speed faster. It will then stay at that full speed for longer, assuming that the connection is being used. Because as soon as these connections stop being used for a period of time, like here you can see this was stopped being used. I mean, only a second, but still after a period of time, TCP goes, okay, I don't know if anything's changed there. I'm going to revert back to my modest slow speed and build up again whenever I get into this request. So you've got two effects here. One is this whole handshake setup, and two is these lines will be longer under HTTP1 rather than they will under HTTP2, assuming that HTTP2 has got a fully primed connection. You might notice that these things only take half as long to download because they've reached full capacity a bit earlier. Okay, so that gives a good view there of a relatively simple site, but you can already see the pain points here. We've got multiple TCP connections happening, and the time and the effort involved to just set those up to get those down there does cause slowness. Now, this is a fairly fast website. It loads in 4.5 seconds and it's there done. But as you get more complicated websites and as you get more complicated apps that need a big JavaScript bundle down, these sorts of pain points get increase exponentially and start causing a lot more pain. This loads a mere 21 assets. 100 assets aren't unusual in websites that load a lot of either a lot of complex JavaScript and data or images, and then as I say a lot of those tracking beacons that we know and love that can spend up and take a lot of time. They'll open separate connections, that's true, and they'll be somewhat separate, but there's still time and effort spent there. And while those are downloading and suddenly hit in there, suddenly you can get a Yankee experience where the website doesn't feel right and it kind of moves around there. So I'm hoping that gives a rough overview of what a waterfall looks like, particularly under HTTP1. Next, I'm going to stick with I think there's definitely something there. So I might just stick with our American test, even though it's a UK site. It's still fairly quick, the wonders of the internet. Next, I'm going to look at the gov.uk. I'll just go straight to HTTPS and we'll run here. And so that's kicked off immediately. So that's the same thing. We're keeping the exact same settings here. Chrome 3G fast. I find this is quite a good speed to choose. You can go faster. You can think, yeah, 4G is what we kind of effectively use in the office, or even broadband there. But this kind of gives a good rough. I don't know if it's average. Some people will be slower, some people will be faster. Typically, if you're on an office network, performance isn't that much of a concern, so you're less worried about that. It also allows it to have the waterfall breathe a little bit and spread out a little bit, so you can actually see it for analysis like this. So here we see gov.uk, and again, because it's a nice UK funded website, it's not filled with a million trackers there, and we've got a fairly small site that fits into one screen. It uses a similar method to the NHS in that it's got the main site here, and then it's got all these asset domains. And here's where you see, so this is obviously an HTTP2 site because it started downloading all these assets straight away. You don't see lots of these connections. You do see one connection to assets.publish.uk, and there's something slightly odd here that we'll explain in a minute. But in general, we've only had to make two connections here. And if we go down to connection view, yes, we can see two connections here as expected. So you can see we're saving all these big, huge gaps here that we saw multiple times over the NHS one. and that's not having to be done here. What's more interesting is that even though we're only using this gov.uk for the main asset, and then we're using these assets, this is using an extra feature of HTTP2 where it can reuse a different domain on the same connection. So we can see down here that this one connection, and if you hover over it, is serving www.gov.uk, but also assets.publishing.service.gov.uk, all in the same connection there. So that's because these domains are both they're effectively virtual domains. They're like vhosts on the same server. They have the same IP address. They use the same HTTPS certificate. So again, if we just go to www.gov.uk, you will see if we view the certificate, and let's go into details of it, you will see that this certificate is valid for gov.uk, but also, I forget the name of the site, sorry, assets.publishing.service. So publishing service, so it's started publishing service. So this certificate is valid for both those sites. And when those two things happen, it's the same IP address and it's the same HTTPS certificate. HTTP is allowed to just effectively say, you know what, I'm just going to reuse the same connection here. I'm not even bother opening another one. We know it's basically the same computer I'm talking to, so that's fine. That can cause some issues if you've set up your server wrong and they aren't really the same, but here it's working very nicely. We don't have that additional lookup here in connection before it can download the first CSS. It can basically do it as soon as it actually sees the site and it can start downloading these. We also don't have this 6 limit. So we're downloading 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 assets here. Well, I could have just taken the 12 minus the 1, but anyway, we're downloading 11 things all at once here. Now, again, our bandwidth is maxing out at a point here, not immediately, but at a certain point it gets up to there. So there are downsides there, and that's one of the things you need to watch out for whenever you move to HTTP2, is are you swamping the connection? Are you downloading a huge image and wasting a lot of your bandwidth on that whenever the CSS or the JavaScript is potentially more important? Under HTTP1, they would be held back by the server, by the browser, because it would be waiting on one of those 6 connections. Under HTTP2, it's not. The connection, the browser can say, here's everything I want, give it to me all at once. There are concepts of prioritization, and the browser can say, this one's really important to me, this one's less important, and the server can say, okay, cool, then I'll hold back that big image and I'll just send you the important CSS and JavaScript and only use that connection whenever I haven't got any of those to send. That's got an interesting history there. Some servers are very good at that, some servers are not, some browsers are very good at that, some browsers are not. So it's really quite difficult to depend on. But in theory, it's there. I just think we're still at the early days of HTTP2, and there's still a lot to be done there to optimize for that. But still, we can see here, we've started downloading everything. Now, these are the fonts, and as I mentioned earlier, they have to be on a separate connection for reasons I'm not going to go into. So that does need a separate connection there. Here we can see it made the connection early, so I'm going to guess that they've got a pre-connect hint going on here. So, I can't quite see that. Assets. Okay, I can't see that there, but at some point anyway, it's realized, let's go back to the thing here, it's realized that it's probably going to, oh, I tell you what, Chrome by default opens 2 connections to the server. And I'm guessing because this connection wasn't used, it could be used for the anonymous connection. So perhaps that's that. I'm not entirely sure, to be honest. But regardless, you can actually see here that we've made, presumably we've made savings from this and we're able to connect there fairly quickly. And just to prove that, another handy feature here is, oh, it's a header, someone's saying. That's someone who possibly works on this website. So let's have a quick look here. And what we do, you can send these hints. So I mentioned earlier that we had a preload hint for the font on the NHS. You can send those in your HTML and say, yep, I want to do this, or you can send it on as a header on the thing here, and there we go. So it's given an HTTP header saying, I'm going to need a cross origin, which is those font requests. I'm going to need that later. You just go ahead and get connected there. We'll get around to using that in a minute and saves us a little bit of time. And you can see because it didn't actually need it, realize it needed it until here, but we would normally expect that's I don't know, half a second delay. So that would have been a half a second delay here, but now we don't do it. As soon as we realize we need this font, there's no waiting time, and immediately can use that pre-connection that's used and start downloading it. Thanks very much for pointing that out, whoever was in the chat. So that's all well and good in theory, and we can sit there and say, yep, HTTP2 is saving the day here, but let's actually have a look at it. So another handy thing that you can do with Webpagetest, and we will again, did I do it? Let's compare like for like. I did HTTPS. So HTTPS. So I'm going to go into one of the advanced settings here. So in Chromium, you can actually sit there and say disable HTTP2, and that's a command line option passed to the chrome.exe executable, and it basically, as the name suggests, says pretend I don't have HTTP, I don't support HTTP2. Oh, there we go, a lovely little advertisement for the book. So if you're ever running Webpagetest and you see that, you can give it a little shout out and have a drink from me. And there's also a discount code on there if you ever want to buy it, or you're looking for a discount code to give to a friend. Yeah, so this will basically say, I don't support HTTP2. All web servers at the minute, whenever they're HTTP2 supporting, they're able to fall back to HTTP 1.1. I think that will continue for a long time, if not forever. So this is loading the exact same site under HTTP 1 rather than HTTP 2. So we don't have this one connection. We have to use multiple connections. We're getting this expensive lookup here. We're only allowed to do 6 at once, so you get this. And this is where, by the way, where the name Waterfall comes from, because you can see it's kind of a waterfall shape as it's moving down, freeing up the connections, adding more things in there and do that. So we can also, now we've got that there, we can go into our test history tab, and we can show these last 2 tests that we've run, and we can compare them. And what I'm going to do is I'm going to rename these just for ease. Once it finishes loading, I'm going to call that one, guessing that's HTTP 1, and I'm going to call that one HTTP 2. And down here you can see the waterfall for both. So let me just refresh the page so it picks up the 2 names that I've given it. So HTTP2, yep, is the one without all the connections. HTTP 1 is the one with all the connections. So you can sit there and you can go back and forth here and compare the loading differences and see what it is. But what's more interesting is this film strip here. So here you can see it does take a little bit of time over a 3G connection. These orange panes show that something's changed there. Sometimes it's not visible, so I can see there's a little bit something there. I don't know if you can quite make out in the bottom. Then it's loading the actual image. So at 1.6 seconds under HTTP2, you basically have the page loaded there. Whereas it takes all the way up till 2.3 seconds there, and even then you don't have most of the content. So we're really talking about 2.6 seconds. So that's a whole second you've saved with primarily HTTP2. Well, no, actually, it's just HTTP2. They are, I mean, this exact same site other than both of those, unless the server's serving things slightly differently. And you can see we've saved it there about half the time it takes to download the website. And that really shows the power of what HTTP2 gives you. A single connection, not wasting all those times doing those, getting that connection up to full speed and pulling it back. means that this website it's taken half the time. And again, this is a fairly simple website with only 24 assets on it. When you start to look at a more complicated one, a typical e-commerce website that's loading lots of um, interesting stuff, junk some might say, but anyway, or a client-side rendered app such uses React or something like that, and it's really at the beginning of that journey of the website that's where it's most important, where you want to actually get a lot of the stuff done. That you can say websites are slow once they get in, once you download the assets, and if they're a very JavaScript heavy website and it's doing lots of things, and that's definitely true. Absolutely, they can be really heavy in the browser, and particularly when you're on a less able mobile device. But all websites suffer from this initial download pain. That's just the nature of what the web is about. Is you have to download the website, you have to see what it needs, and you have to download the rest of the assets that the website needs. And HTTP2 really helps with that. Its primarily aim was to just to speed up that and remove some of the inefficiencies of HTTP1, where there was an awful lot of back and forth and setting up connections to actually do that. And that was fine whenever the HTTP first came along and we were using very simple websites. But the web has grown to a hugely complex application almost nowadays, and the websites are getting more complex. So as I mentioned earlier, we're getting about 100 assets per domain is not unusual, and you get there doing that. So HTTP1 is really showing its age there and showing how inefficient it could be, and TCP to some respect as well. So the next thing that the IETF, which I see someone's mentioning in the chat, is working on is HTTP3, which will fundamentally at an application layer from the way we think about it, isn't that different from HTTP2. HTTP2 is probably a bigger leap there to what web developers need to think about, but the HTTP3 is built upon a UDP-based protocol rather than a TCP-based protocol. It's a reimagining of TCP in a protocol called QUIC, and that's going to look at trying reducing and making more efficient the TCP part of this. But it's building upon what we've done here with HTTP2, where we can have this concept of a single connection and packets going back and forth belonging to multiple streams within that connection, rather than HTTP1, which was each connection owns the whole connection, and you can assume in effect everything is for that one request until it's finished and done with there. So I think this website is a great example of where the gains that we got just by moving to that. You can see it's simple. A second may not sound like much, but that's the other way of looking at it. Is it's 50% faster. It's taking that much less time to actually do there. And there's been numerous studies that show the cost of slow websites, and for every second longer it takes, you lose X percentage of your visitors, or your conversion rates drop down by a certain amount. Whereas here you can see, hopefully, just by flicking a switch in the web server, you should be able to see real gains there. And I think a tool like Webpagetest makes that more obvious, whether it's in advance, whether you look at a site and say, hey, I can see lots of this slowness, or whether it's after you've turned it on, you can look back and say, okay, right, I know I've turned it on and I can pat myself on the back, but what did it really gain me? And you can use these sorts of views to actually see, yeah, it made a huge difference there. We got a second gain on loading the website there, and it's it's completely loaded the first time it's there. It's not like the first thing comes in there, it's not got any text, you've got to wait a little bit longer, and then it comes in there. And again, for your office or your fancy high-speed network at home, that might not be a big difference, but I think we've all been in those things where we're out in patchy area, be it in the countryside or in a congested city in the middle of London I used to work in, and that doesn't have the greatest connection purely because of the volume of people there all trying to use the same mobile masts, and you can get really slow connections. Or whenever you're sharing your internet cafe website and it's with a million other people all trying to work away at the same time, it's just painfully slow. And HTTP2 is one of those things that I like, that in theory just makes that better with hopefully minimal effort. Now, saying that, there's an awful lot of complexities with it, and things that can be different, and sites can actually be slower under HTTP2 rather than HTTP1 for some of the reasons I touched on earlier, where we're we're kind of clogging the pipe with everything rather than having this natural 6 assets at a time flow that HTTP1 enforced. And there's also an awful lot of things where HTTP2 failed to deliver. It was supposed to be this switch on, everything's beautiful and everything's wonderful, and web developers can forget about all these workarounds that we had to give for HTTP1. The reality, as ever, is a bit more nuanced than that, and it's taking a little bit more effort, and some things have gone right and some things have gone wrong. But in general, I think this sort of test here shows where it can be powerful. And at that point, those are the main things that I wanted to cover. So I'm going to open up and I'm going to have a quick flick through the chat there and see what people are suggesting there. Shout out to the IETF for coming up with and standardizing HTTP2. Absolutely. It was based on the Google protocol, so I'm going to give a shout out to them. They get an awful lot of stick for waving the big stick about, but I think they've done well with this. They came up with a protocol called Speedy, and they showed it working everywhere, and without that, I don't think we would have done that. HTTP1 has really changed fundamentally in about 20 years, whereas I think this was a big leap forward, and it leaves a lot of opportunities there going forward. So I'll give credit to both Google and the IETF for that. And while I'm on that, I would say, a lot of these standard organizations are working by very hard people working in the background, often in their spare time, on top of their day jobs, and we're all benefiting from that. So we'll see. I was wondering if they're only using their. How about Internet Engineering Task Force (IETF)? I was wondering if we're using their own improved standards. Sorry, Grey Programmer, I don't fully understand what the question is there. We have, if they enable HTTP3 in Cloudflare, one could check with Chrome Canary. So as I mentioned, HTTP3 is almost there. It's actually due to, well, it's been delayed a few times, but I think we're pretty close for that coming in. And it's starting to be rolled out in some of the CDNs, and some of the browsers have got enabled it, so you can get early previews of that. So if you're on Cloudflare, your websites, you can enable it, and if you're using Chrome, you can actually turn things on and actually connect to that. Again, it's based on another Google enhancement there, which has been used on all the Google websites for quite some time there. For what it's worth, the performance of loading IETF spec documents could be improved with better HTTP caching. I suspect that that's someone who actually works at the IETF is having a little bit of a moan there. But yeah, it is actually surprising whenever you see those. I notice the Apache website is still load over HTTP2 or HTTP, not HTTP2 and not HTTPS. Nginx is the same. Yeah, I think sometimes some of these people working on it, you think they would know better themselves, but there we go. Okay, so I say that's kind of me covered. If anyone wants me to run through another website, then feel free to stick it in the chat. I've got a bit of time now. Other than that, I will leave it up to yourselves and end it there if no one has any suggestions. So I'll give it a couple of minutes. I hope that was useful. It was a very quick view through the whole system. I think Webpagetest is a lot that you can go into there. There's an awful lot of more detail in there. And I think the HTTP2 protocol has an awful lot to it, a whole book's worth. I can wholeheartedly recommend my own book on that. So if that was interesting to you, then have a read through that. You can read it online at manning.com for free for a few minutes every day. And if you like it, then feel free to go ahead and purchase that and download it either as an ebook or as a full book. It's also available at Amazon and all good bookshops. Anyone that doesn't store it is not a good bookshop. Okay, I will leave it there. I can't see anything in chat. I'm hoping that was useful, and feel free to reach out on Twitter. I am Tune the Web on Twitter. Let me just get those details back up for you again. And I'm always available to chat about this sort of thing, and hope that was useful. Thanks very much. Cheers all.